Every year, more than 35 billion liters of fruit juice are consumed worldwide, enough to fill 14,000 Olympic-sized swimming pools into a single massive body of liquid, spanning everything from pure juices to globally standardized fruit concentrates. But how do fresh fruits from distant continents preserve their flavor, structure, and stability when even a few hours delay after harvest can trigger quality decline? In this video, we step inside some of the world's most advanced juice processing plants, from Brazil and Poland to Costa Rica, to follow a precisely controlled journey, measured down to the hour, from vast orchards to the seemingly simple glass of juice on your everyday table. In the world of tropical fruits, orange juice stands at the pinnacle of industrialization, thanks to its unparalleled capacity for concentration and flavor standardization. Yet few realize that behind this seemingly ordinary glass lies a dramatic shift in power, as Florida gradually relinquished its historic dominance to Brazil, a country that now controls nearly 70% of the global industrial orange juice market. The key lies in São Paulo state, where iron-rich basaltic soil, combined with almost military-grade production discipline, has transformed fresh oranges into a form of liquid gold, governed by some of the strictest standards in the world. From July through February, São Paulo enters a massive harvest campaign, yielding over 12 million tons of oranges. Despite the scale of industrial operations, harvesting is still carried out entirely by hand under uncompromising rules. Oranges are never allowed to touch the ground. A single contact with grass or soil is enough for immediate rejection, eliminating any risk of bacterial or yeast contamination from the earth. Instead of pulling or tearing, workers use a precise wrist-twisting technique to keep the stem and outer peel completely intact. This is a strategic requirement, because even the smallest scratch that releases peel oil can introduce bitterness and compromise the purity of the juice. Everything moves at extreme speed. Oranges must reach the presses within 4 hours, the critical window to lock in vitamin C before oxidation begins to interfere with the fruit's original flavor profile. Inside the plant, the production cycle accelerates as gondola trailer trucks arrive one after another. Each trailer carries up to 120,000 oranges, feeding the massive extraction lines that lie ahead. Unloading takes place on hydraulic tipping platforms, where entire trailers are tilted at 25 degrees or raised nearly vertical to harness gravity. Within seconds, hundreds of thousands of oranges cascade onto conveyor belts, marking the official starting point of the processing journey behind the world's most widely consumed juice. From the intake basin, the oranges move through pre-washed tanks, where they are sprayed with a food-grade alkaline solution combined with high-pressure water. At the same time, a series of continuously rotating brushes scrub the peel surface, stripping away dirt and environmental microorganisms. This is a critical control step in industrial processing. The peel must reach near absolute cleanliness before entering the extraction machines, preventing any risk of cross-contamination that could alter the flavor integrity of the juice. After washing, the oranges enter the grading stage to optimize extraction efficiency. First comes mechanical screening, where the fruit rolls across parallel cylindrical bars with progressively wider gaps, rotating to inspect the surface, while gravity allows each orange to drop into the correct chute according to its diameter. Operating at a throughput of 2,000 to 3,000 oranges per minute, the line maintains a steady and continuous flow of raw material. Next is manual sorting, where workers serve as the final quality control layer, removing damaged or defective fruit. At this point, the line is strategically split. Oranges with flawless appearance are directed to the fresh fruit market, while the juiciest fruit is sent straight into the extraction system, the operational core of the plant. Here, the most critical stage of the process begins. Oranges are fed into extractors, operating at up to 800 fruits per minute. Depending on the technology, the machines use either rotating conical reamers or decisive metal prong systems to separate juice and pulp from the peel in a single motion. The hollowed peels are then crushed and repurposed as livestock feed, while the orange pulp is collected in heavy-duty plastic liners and stored inside sealed metal tanks to prevent oxidation. After thermal processing, the orange juice is pumped into specialized refrigerated storage tanks with capacities of up to 1 million gallons. Within a sterile, tightly temperature-controlled environment, the juice can preserve its vitamin content intact for up to 2 years, without the need for any preservatives. At the final stage, the juice is filled into plastic bottles that have been thoroughly sterilized. To completely prevent recontamination, hot filling is carried out at a controlled temperature of approximately 80 degrees Celsius, eliminating any remaining microorganisms inside the packaging. Once sealed, each bottle passes through a high-speed camera inspection system, capable of detecting even the smallest defects, such as misaligned caps or microleaks, to ensure absolute airtight integrity. Finally, the standardized juice batches are labeled, palletized, and transported in refrigerated trucks to destinations around the world. From here, orange juice moves beyond supermarket shelves to become a core ingredient across multiple industries, from food products like dairy and confectionery to cosmetics manufacturing and the extraction of vitamin C for global nutritional and pharmaceutical supplements. In Poland, massive apple production is both an advantage and a burden. Prolonged oversupply has meant that in many seasons, apples are left to fall and rot in orchards because harvesting costs exceed market prices. Yet this very paradox has opened an alternative path. Nearly 2/3 of Poland's apple output is sent directly into industrial processing lines, allowing the country to capitalize on low-cost raw material and rise to control around 25% of the global apple juice concentrate market. From September through November, the harvest unfolds at an intense pace under strict requirements, designed to preserve maximum commercial value. Workers do not pull or tear apples from the branch. Instead, they use a lift and twist technique. This method keeps the stem intact and preserves the apple's natural wax layer, a biological shield that protects the skin from environmental stress. A skilled worker can harvest up to 200 kilograms of apples per hour, filling dozens of specialized fabric-lined picking bags without leaving a single bruise on the fruit's flesh. As labor costs in Europe have risen by more than 25% in just a few years, fleets of AI-powered drones have been deployed across Poland's apple orchards as a profit optimization solution for the juice industry. Equipped with AI systems, LiDAR sensors, and multispectral cameras, the technology can scan entire tree canopies within seconds, accurately analyzing each fruit's size and pigment accumulation without making physical contact. Once a target is identified, a vacuum-assisted robotic arm gently harvests the apple with controlled suction, reducing bruising rates to nearly zero. A significant advancement over traditional mechanical shaking methods that often cause severe tissue damage. Each system can operate 24/7, achieving productivity of up to 1 ton per hour, enabling growers to seize the optimal harvest window, precisely when apples reach their ideal sugar levels. The journey begins with a comprehensive purification process as soon as the apples arrive at the facility. They are immediately directed into a recirculating water tank system with continuous aeration. Here, the combination of dynamic water flow and a safely diluted chlorine solution works to remove soil, dust, and residual crop protection chemicals from the surface. The apples then move on to a roller conveyor equipped with high-pressure spray nozzles to complete the cleaning stage, ensuring that each fruit reaches maximum surface purity before advancing deeper into the processing line. Washing alone is not enough. The apples must be dried immediately to prevent microbial growth. A system of high-capacity air blowers, working in coordination with soft brushes, eliminates all surface moisture. At this stage, a direct inspection team carefully monitors the line, removing any bruised or physically defective fruit, ensuring that only the healthiest raw materials proceed further. Immediately afterward, the grading process moves into a more advanced technological tier. Through a network of high-resolution cameras and sensors, the system automatically analyzes color, size, and even internal defects that are invisible to the naked eye. Based on this real-time data, a pneumatic sorting system directs the flow. Fruit that fails to meet visual standards is diverted to the juice extraction line, while flawless apples are packaged for the fresh export market. Once grading is complete, the apples reach a structural turning point. They are fed into a high-capacity crushing machine equipped with high-speed rotating blades. Under intense rotational force, hundreds of tons of apples per day are rapidly reduced into a mixture of pulp, juice, and peel. The result is a uniform apple mash, the critical raw material for the subsequent juice extraction stage. The crushed mixture is immediately transferred to a modern belt press system to recover the valuable juice. Thanks to its continuous operation and high efficiency, this method preserves the apple's natural flavor. The dry pomace is not wasted, but repurposed as livestock feed or raw material for the pharmaceutical and cosmetics industries, maximizing the overall value chain. The extracted juice is then filtered to remove residual solids and impurities, before being sent to heated agitation tanks, maintained at 35 to 45 degrees Celsius, to stabilize enzymes and break down pectin bonds for optimal clarity. Once the desired clarity is achieved, the juice undergoes rapid cooling to lock in flavor, followed by tubular pasteurization with instant heating and cooling, eliminating microorganisms while preserving the fruit's essential qualities. While the juice is being prepared, a parallel cleaning system sterilizes the empty bottles using sterile water or high-pressure air at 80 degrees Celsius, eliminating any potential microbial contaminants. Finally, the automated line performs filling with absolute precision in a sterile environment. The caps are immediately sealed to create a perfectly airtight space, followed by labeling with full traceability codes, ready for distribution to consumers. From jams and dried fruits to IQF frozen products, this field is gradually breaking the long-standing dominance of industrial snacks and traditional confectionery in the convenience food market. So how are more than 900 million tons of fresh fruit, highly perishable and closely tied to seasonality, processed into snack products that can be stored year-round? In today's video, join Agriculture Insight as we explore the entire journey that transforms fruit-producing regions across continents, with massive output and extremely high loss risks, into a top-tier food processing industry, where modern farming practices and advanced processing technologies are reshaping how people produce, preserve, and consume fruit. Everything will be revealed right now. Let us begin the journey with the first stop in California, the hub that accounts for up to 90% of U.S. strawberry production, thanks to a unique convergence of coastal loam soils and Pacific Ocean fog. All operations here run like a precision-driven system, especially during the peak harvest season from April to June. Harvesting starts before dawn to take advantage of the lowest thermal conditions, allowing cellular tissue to achieve maximum stability and withstand physical handling without bruising. Unlike fresh market produce, strawberries destined for jam processing are harvested precisely at 80% ripeness to capture peak levels of natural pectin, the gelling agent that creates elasticity without the need for additives. Despite the massive scale, hand harvesting remains a mandatory standard to protect the highly sensitive skin, just 0.1 millimeters thick, equivalent to a human hair, yet responsible for bearing the full stress of deep processing. Instead of applying direct pulling force that can tear the tissue, farmers use a technique of sharply pinching the stem with their fingernails, leaving an exact 1 centimeter segment intact. This action establishes a biological barrier that shields the fruit core from bacteria and prevents premature internal oxidation. With yields reaching 40 tons per acre, California has become a strategic supply source for the global processing industry. To lock in quality, a critical 60-minute golden window begins the moment the fruit leaves the plant. Otherwise, strawberries enter self-respiratory breakdown, causing the loss of valuable sugars and aromas before they ever reach the factory. At the factory, strawberries arriving from the fields enter a rigorous industrial purification process. As the first step, all strawberries are thoroughly washed using recirculated cold water, combined with air bubbling and low-pressure spraying to remove soil and surface residues without damaging the fruit tissue. Once the washing process is complete, the strawberries are transferred to an automated stem and leaf removal system, using optical positioning combined with precision cutting blades to eliminate the green parts without damaging the fruit tissue. This step ensures uniform, fully cleaned input material free from plant debris. When only the intact red flesh remains, the strawberries are fed into cutting and primary crushing machines. Depending on the product line, the mixture may retain large fruit pieces for chunky jam, or be fully pureed to create a smooth, spreadable texture. The next step, and the most critical transformation stage, is heating and concentration. The strawberry mixture, retaining pieces or fully pureed, is cooked in vacuum kettles or indirect heated vessels at around 65 degrees Celsius under low pressure. This process activates natural pectin, removes up to 40% of free water while preserving red color and aroma, creating the characteristic thickness of strawberry jam. Next, sugar and organic acids, primarily citric acid, are precisely added to balance sweetness, gel structure, and microbial safety. The mixture is adjusted to optimal Brix levels and pH, allowing natural pectin to form stable bonds and create a uniform, non-separating gel structure. Through this standardization process, the jam can be preserved for up to 24 months, while fresh strawberries maintain quality for only a few days after harvest. At the same time, air bubbles are removed to prevent oxidation and separation. A slow stirring system ensures a smooth, uniform jam structure. After approximately 30 to 45 minutes of cooking, the finished jam is carefully cooled to around 75 to 80 degrees Celsius before entering the jar filling stage. On the automated production line, glass jars that have been cleaned are fed into the volumetric filling system, where the jam is filled while still hot, with precise volume control and minimal deviation, ensuring uniformity across products. Immediately afterward, metal lids are sealed instantly, creating a natural vacuum environment as the jam gradually cools. The combination of hot filling, vacuum sealing, and high sugar content allows the jam to be stably preserved for up to 24 months without the use of chemical preservatives. After sealing, the jam jars undergo final sterilization before entering the automated labeling line. In the final stage, the products are grouped into standard packs, ready for market distribution. At the next stop, let us head to the Aegean region of Turkey, the center of the global dried fig industry. From fig trees thousands of years old, the country controls up to 60% of the world's dried fig market, with export values reaching $250 million USD per year. In the Aegean region, where summer temperatures frequently exceed 40 degrees Celsius and dry Mediterranean winds blow continuously, Sarlop figs, the leading golden fig variety in the global dried fig industry, self-concentrate directly on the tree. Water evaporates slowly while sugars are retained within the fruit tissue, creating a stable, chewy texture and authentic flavor, an advantage that artificial heat drying struggles to replicate due to excessively rapid moisture removal. However, this very mechanism of natural dehydration creates the greatest harvesting challenge: asynchronous ripening. On the same branch, each fig reaches a different level of dryness from day to day, forcing more than 30,000 farming households in Aden to remain constantly present in their orchards throughout the harvest season. Harvesters use long poles to gently tap the branches. Only figs that have reached the standard dryness threshold naturally detach from the stem and fall onto nets, while fruits that are still moist remain on the tree to complete the concentration process. This method not only protects the thin, easily damaged skin, but also acts as an on-site moisture control step, reducing early risks of mold and microbial growth from the moment of harvest. Building on this level of control, the crucial drying stage is carried out based on the principle of natural convection, rather than cold drying technologies used by Americans for the Mission Black Fig variety. The figs are spread evenly on raised wooden racks for 3 to 5 days, allowing bidirectional airflow to remove moisture uniformly from the core to the skin. Once moisture levels fall to a safe threshold, the concentrated sugar content becomes sufficient to naturally inhibit microbial growth, enabling the figs to maintain stable quality for up to 12 months without the use of chemical preservatives. To meet export standards, the figs are sent directly to processing facilities for cleaning and standardization. The process begins with mechanical screening on vibrating conveyor belts, where broken figs, foreign materials, and undersized fruits are removed, leaving only uniform and intact figs to proceed to subsequent processing stages. After being cleaned and dried, the figs are hand-sorted by skilled workers. Only the finest fruits earn the tender and juicy label, certifying a soft skin, syrupy interior, and an ideal moisture level of around 24%, delivering a naturally concentrated sweetness. Finally, qualified figs are fed into vibrating hoppers and automatic weighing systems before packaging, helping preserve their soft, juicy structure and limit moisture reabsorption or oxidation throughout transportation. Highbush blueberries, accounting for up to 80% of global production, have become the star of the industry thanks to their ability to ripen uniformly, enabling large-scale mechanized harvesting. Every June, Oxbow steel giants begin their deployment across farms stretching from Oregon to Washington, USA. Their distinctive arched frame design allows the machines to envelop entire rows of bushes, moving through dense canopies without the need for cleared pathways. At the heart of the system is a dual-axis shaking unit capable of interpreting ripeness. By precisely adjusting vibration frequencies, the machine detaches only berries that have reached optimal sugar levels, leaving unripe fruit untouched. With a capacity of up to 400 kg per bin, this technology enables large-scale farms to operate 24/7, sustaining outputs of tens of tons per day. The first step in the process, and also the critical stage that determines the quality of frozen blueberries, is washing. Upon entering the plant, the blueberries are passed through a recirculated cold water washing system, combined with air bubbling and gentle water flow to remove dirt, dry leaves, and residual debris from mechanical harvesting. The entire operation is designed to minimize impact on the fruit surface, as blueberry skins are very thin and prone to cracking under high pressure. After being washed with purified water, all blueberries enter the optical sorting stage. Here, multispectral cameras scan each berry in 360 degrees, analyzing color, shape, and surface damage in real time. Any berries that fail to meet color standards or show bruising or tissue cracking are immediately removed by high-speed air jets without mechanical contact. Only berries that are round, plump, and highly uniform are retained as qualified raw material, ensuring consistency in quality, structure, and sensory characteristics from the very first control stage. Once the sorting process is complete, all blueberries are transferred to the heart of the plant, the individual quick freezing (IQF) system. The key to a frozen blueberry retaining its original character after thawing lies in freezing speed. Instead of conventional slow freezing, which can cause clumping and juice leakage, blueberries are passed through a freezing chamber with temperatures dropping to -40°C. In this environment, each berry is kept suspended by powerful streams of cold air, allowing it to freeze almost instantly and remain completely separate. This process not only locks in the fruit's cellular structure, but also freezes in the full content of anthocyanins, responsible for the deep purple color, and vitamins, the valuable antioxidants that define blueberries as a superfood. Welcome to Mexico, the homeland of the cactus, where this spiny plant is regarded as one of the nation's strategic crops, leading the world in production with hundreds of thousands of tons harvested each year. More than just an enduring cultural symbol, the cactus serves as a vital source of food, industrial materials, and livelihood for millions. The prickly pear industry alone brings in over $100 million annually for Mexico. Beneath its thorny skin lies a sweet, refreshing flesh with a flavor blend of watermelon, pear, and kiwi, rich in vitamin C, packed with minerals low in sugar, making it ideal for diabetics and earning its place among the world's most promising superfruits. As the pads settle into the earth and begin to awaken life within, growers resist the urge to water immediately. For the first 2 weeks, the soil is left dry, encouraging the roots to stretch deeper in search of moisture hidden in lower layers, a natural response that helps the plant establish a stronger foothold in harsh environments. Only when new shoots begin to emerge, those first subtle signs of life, does irrigation begin. Water is applied sparingly, just enough to moisten the soil without making the plant dependent on external sources. With cactus, it's not about how much water is given, but when it arrives, a perfectly timed nudge that tells the young plant it is ready to thrive in a dry and demanding world. When the dry season lingers long enough and the sun has scorched the edges of each cactus pad to a golden hue, the prickly pears begin to ripen, changing from green to amber, then to deep red, swollen as if they've gathered the desert sunlight beneath their delicate skins. This marks the start of the first harvest, a task that must be done gently yet cautiously, as these fruits are both fragile and covered in nearly invisible hair-like spines. Harvesting usually takes place in the early morning when the sun is already casting its light across the desert. Farmers dress in long sleeves, gloves, and wide-brimmed hats to shield themselves, carefully stepping between rows of spiny plants. Using steel tongs or curved knives, they skillfully twist each fruit, detaching it from the pad with a light motion, taking care not to tear the thin skin or release the ultra-fine spines that can lodge deep in the skin and cause hours of irritation. Each fruit, once picked, is gently dropped into bamboo baskets or plastic tubs kept nearby, making it easy to move through the rows while minimizing handling and contact. Once the last prickly pears have been gathered, farmers return to a familiar rhythm, harvesting the nopal pads, the tender green stems often referred to as the lungs of the cactus. What seems like a simple task actually demands great precision, as even a slight miscut can damage the mother plant and disrupt its entire growth cycle. The selected pads must not be too old or woody. Their surface should still be smooth, evenly thick, and tinged with that signature jade green. With a razor-sharp knife, the worker makes a swift yet delicate cut close to the base, carefully avoiding the bud eyes. Tiny growth points where even a small scratch can prevent new shoots from sprouting. Every cut must be clean, exact, as if the cutter understands the biological rhythm pulsing beneath those layers of spines. Roughly every 7 to 10 days, new pads emerge, and the cycle repeats, like a steady breath across the desert landscape. At larger farms, semi-automated machines are now used for harvesting, reaching speeds of 500 to 700 kilograms per hour, resembling combine harvesters in arid terrain. Yet, not every field is flat, and not every cactus grows in neat rows. In rugged hillsides where the earth cracks like dried skin and plants grow wild, each cut is still entrusted to human hands, where technique, intuition, and years of experience preserve something no machine can replicate: the art of cutting to keep life alive. Immediately after harvest, both cactus pads and fruits are carefully stacked into ventilated plastic crates and quickly transported to the processing facility. The transport must be completed within the same day to prevent sun exposure from dehydrating the produce or causing the sap to ferment, since just a few hours under the heat can significantly alter the quality. For such perishable crops, speed and gentle handling are critical to preserving freshness. At the processing facility, crates are unloaded by hand or with small forklifts and neatly arranged into batches in the staging area. The space is cool, sheltered, and has clean flooring, helping to reduce temperature shock as the produce transitions from intense sun to shade. Each pad is then manually sorted, rinsed with cold water, gently despined, and left to drain for about 30 minutes. Pads that meet quality standards are packed according to their destination: whole pads for restaurants, sliced portions for supermarkets. Every package is labeled with traceability information and stored in cold rooms at 4 to 8 degrees Celsius, cool enough to preserve the vibrant green color, yet mild enough to retain the pad's natural flavor. Nopal pads that don't meet commercial standards are set aside for a different purpose, becoming a green source of nutrition for livestock, especially cattle and buffalo during the dry season. After being washed and despined, the pads are fed into specialized shredders, where they are either sliced into 2 to 4 centimeter strips or ground into a soft, wet mash that's easy to digest. At larger farms, chopped straw, sugarcane pulp, or dried grass is often mixed in to balance nutrients and increase roughage. Modern machines can process 1 to 1.5 tons of cactus pads per hour, an impressive output considering that in many semi-arid regions, this is the main source of feed keeping livestock alive through the dry season. With a water content of up to 90% and rich in potassium, calcium, and natural mucilage, Nopal helps animals stay hydrated, improves digestion, and reduces heat stress. In sun-scorched areas where even grass withers, Nopal becomes a living water tank for livestock, quietly feeding and hydrating herds without a single drop of rain. After a short journey from field to facility, the prickly pears rest quietly in crates, as if returning from a harsh expedition. Their skins remain plump and vibrant, yet are coated in dust and lined with fine spines, so delicate that a single touch might release an invisible cloud of needles, sharp as the desert's thoughts. To cleanse this natural armor, the fruits pass through soft brushes, rotating slowly under cool water, where each spine falls away like the last grain of sand slipping from the hand of the wind. Water pressure, rotation speed, the tilt of the conveyor belt, everything is calibrated not just by machines, but by experience. For the skin of the prickly pear is as fragile as the final breath of ripeness on the surface of fruit. On large farms, a single machine can process 400 to 600 kilograms of fruit per hour. Yet speed is never prioritized over precision, because even the smallest scratch can begin the fruit's decline within hours. Once the dust and fine spines have been removed, the prickly pears move on to their final stage: packaging. Workers select the fruit using both sight and experience, not just to pick the most attractive ones, but to ensure perfect ripeness and firmness. Fruits that meet the standard are carefully arranged in ventilated trays or mesh bags, labeled with their origin and packing date as a promise of quality. Finally, they are placed in cold storage at 8 to 10 degrees Celsius to preserve their freshness and flavor all the way to the consumer's hands. In addition to daily fresh consumption, a significant portion of prickly pears is sent to processing plants, where the ripe, succulent fruits continue their transformation into a variety of high-value products. After being peeled, either manually or using semi-automated machines, the fruits are deseeded and fed into cold press extractors. With a capacity of 500 to 800 kilograms of raw fruit per hour, these systems can handle dozens of tons each day while preserving the purity of the juice. The result is a vibrant pink-orange liquid, glowing with a natural radiance, as if infused with the essence of dry soil, scorching winds, and late-season rains. This isn't just juice, it's a nutrient-rich concentrate, packed with vitamin C, flavonoids, and especially betalains, powerful antioxidants with anti-inflammatory properties up to 3 times stronger than those found in beets. Though not every drop of cactus juice ends its journey as a refreshing drink, some are reserved for a quieter transformation into wine. In cold steel tanks, the vibrant pink-orange liquid undergoes natural fermentation over 7 to 10 days, guided by probiotics and steady temperatures. Once the wine has matured, it is filtered and left to rest, gradually turning into a clear ruby-red hue. A single sip reveals a delicate sweetness that touches the tip of the tongue, carrying the essence of dry earth, blazing sun, and the art of finding pleasure amid harshness. From edible pads to juice, from fresh fruit to fermented wine, the cactus proves that even the most rugged things can reveal gentle beauty when respected and understood. This journey isn't just the story of a plant, but a testament to resilience and adaptation, lessons both nature and humanity are relearning in an increasingly arid and changing world. If India is the mango capital of the world, producing over 50% of the global mango supply, then the United States is the world's largest consumer market for imported mangoes, with a skyrocketing growth rate that has surpassed many other tropical fruit juices like pineapple and guava. Although mango cultivation is expanding in states like Florida and California, domestic production still falls far short of meeting demand. That's why the U.S. spends over $1 billion each year importing mangoes, primarily from Mexico, to satisfy its enormous appetite for this tropical fruit. Mangoes are a guilty pleasure for strict dieters, with a single ripe fruit packing up to 40 grams of sugar, about the same as a can of soda. But for the rest of the world, they're known as tropical gold, sweet, fragrant, and packed with nutrients. And what about you? Are you on team sugar shy? Or do you melt at the first taste of juicy, sun-kissed mango? Although technology in the US is highly advanced and mango harvesting robots have begun to emerge, equipped with sensors to detect ripe fruit and robotic arms to pick each mango, this technology is not yet widely adopted. That's because harvesting mangoes isn't easy. The fruit bruises easily and trees are tall with wide canopies. As a result, hand-picking remains the most common method. Even so, machines still play a supporting role, with tools like lifts, conveyors, and creative harvesting devices helping boost efficiency and reduce manual labor. Every April, as mangoes begin to ripen and turn golden under the warm sunlight, the bustling harvest season kicks off. Each mango is carefully inspected right in the field before being picked. Don't be fooled by appearances. Not every golden fruit is ready. Each mango variety has its own ripeness cues. Some turn from green to yellow, others take on a rosy blush, and some can only be judged by gently squeezing the skin to check for just the right firmness. For low-hanging mango trees, harvesting is done entirely by hand. Farmers gently hold each fruit, feeling for ripeness through its taut skin and just right softness. A skill that may seem simple, but actually requires experience to avoid bruising the flesh. When mangoes are out of reach, harvesters use a specialized stem cutting tool, a long pole equipped with a sharp gripping head. This design allows them to reach each mango from the ground and gently cut the stem without causing the fruit to fall or bruise. For taller trees, especially on large-scale farms, hydraulic lifts are used, like a mechanical arm that raises workers safely to reach thick, towering canopies as high as 5 to 6 meters. This blend of traditional techniques and modern support makes mango harvesting more efficient, safer, and less labor-intensive. On average, one person can harvest up to 1,200 mangoes per day, depending on the height of the trees, fruit density, harvesting technique, and weather conditions. Especially when cutting the stem, farmers must leave a small portion attached to the fruit to prevent sap from oozing out and damaging the skin or staining other mangoes. That's why, right after harvest, the stem of each mango is rinsed with a gentle stream of pressurized water to remove the sticky, irritating sap. This simple step not only helps the fruit maintain its fresh appearance, but also extends its shelf life, especially important during long-distance transport or export. Mango sap is highly acidic and can cause skin irritation, burning sensations, or allergic reactions upon direct contact. That's why during harvest season, gloves, arm sleeves, and protective clothing are essential gear for professional mango growers. After harvest, the mangoes are quickly transported to nearby processing facilities to preserve their freshness. The ripe mangoes are placed into large red plastic crates specifically designed with ventilation holes on all sides. These openings help keep the fruit cool and well ventilated, minimizing heat and moisture buildup, and significantly reducing the risk of spoilage during transport. After a bumpy ride aboard heavily loaded trucks, the fresh crates of mangoes finally arrive at the processing facility, where their true transformation begins. Here, workers will conduct a preliminary inspection, carefully selecting the mangoes that meet the required standards, while discarding those that are damaged, bruised, or show signs of disease. Only the finest fruits will proceed to the next stage of the process. Next, the mangoes are placed into a water bath or a continuous flowing water stream, where the gentle sound of water not only helps remove dirt but also cools the fruit, preventing premature fermentation and keeping the mangoes fresh. After the preliminary wash, the mangoes are passed through a high-pressure water spray system, where powerful jets of water clean off any remaining impurities and bacteria from the skin. The spray nozzles are automatically controlled, ensuring that each mango is evenly washed without the need for manual intervention. This not only boosts efficiency, but also reduces the risk of direct contact, all while maintaining the highest quality of the product. The mangoes are soaked once again in a sanitizing water solution, typically ozone water, a method that not only helps eliminate bacteria and mold. Then the mangoes move on to the drying area. Here, they gently roll along a conveyor belt lined with soft, wave-like padding, designed not only to prevent scratches but also to absorb any remaining water on the fruit's surface. Some factories also install overhead air-blowing systems to speed up the drying process, ensuring the mangoes are completely dry before entering the sorting and packaging stages. After being thoroughly washed, the mangoes travel along a conveyor system and pass through a scanner equipped with automatic sensors that sort them based on size, color, and ripeness. Mangoes that meet the standards in shape and show no signs of bruising or damage are sent to the next processing stages, while undersized, substandard, or damaged ones are redirected for processing into other products, depending on specific criteria, such as mango juice or dried mango slices. Mangoes that meet the quality standards after sorting are labeled with traceability information, clearly stating the place of origin and packing date. Each fruit is carefully placed in plastic trays or cardboard boxes lined with soft foam to minimize impact during long-distance transportation. For premium varieties like Honey Gold or Nam Dok Mai, each mango is additionally wrapped in protective mesh to preserve its shape and extend shelf life. The mangoes are then stored in cold rooms at an ideal temperature of 10 to 13 degrees Celsius, with humidity around 90% to maintain their crisp texture and vibrant color. Once all quality standards are met, the mangoes are packed into large cartons and shipped in refrigerated containers to supermarkets, restaurants, and retail chains around the world. And while the highest quality mangoes are carefully packaged for destinations around the world, the remaining ones embark on a different kind of journey, a magical transformation inside modern processing factories, to be transformed into a wide variety of mango-based products. First, let's take a closer look at the frozen mango production line, where ripe, juicy mangoes are flash frozen step by step to preserve the full taste of summer all year round. After sorting, each mango is securely fixed onto a specialized holder. Then, an automated blade system peels off the outer skin with a rotating motion, carefully preserving the fruit's shape and flesh. Next comes the cheek cutting stage, a task that requires both skill and precision. Since mango flesh is soft and easily bruised, most factories still perform this step manually, despite having modern production lines. Then the mangoes are washed again, using a foaming solution and air pressure to remove any remaining dirt, then quickly dried by an automated lifting system before moving on to the next processing stage. After the cheeks are separated and the seed removed, the mangoes are fed into an automatic cutting machine that slices them into uniform cubes. Sharp, high-speed blades process thousands of pieces per minute with high precision, ensuring each cube is the ideal size for freezing. Ever wondered how frozen mango cubes stay loose instead of clumping into a solid block? The secret lies in the vibrating mesh system. As the cubes move along a stainless steel tray, continuous shaking spreads them evenly and removes excess surface moisture. This small step makes a big difference. By minimizing moisture, it prevents ice buildup and keeps the cubes separate. Modern IQF lines can freeze 2 to 3 tons of mango per hour, dropping the temperature to minus 35 degrees Celsius in under 20 minutes. After freezing, the mangoes are packed into moisture-resistant cardboard boxes lined with plastic film, each weighing about 5 to 10 kilograms. The boxes are sealed, fully labeled, and stacked on pallets, ready to be stored in cold rooms for export. The magic of delicious mangoes doesn't stop there. Mango isn't just turned into crispy snacks, it also drives millions of people crazy for the iconic, chewy dried mango. Once the mango is ready, golden mango slices are gently placed into the drying chamber. Here, they undergo a slow drying process in a tightly controlled environment, typically between 50 and 60 degrees Celsius. The drying period lasts from 10 to 14 hours, depending on the thickness of the slices and the ripeness of the fruit. This process reduces the moisture content to an ideal level while preserving the mango's natural color, sweet flavor, and irresistibly soft, chewy texture. After drying, the soft mango slices are removed from the trays and sealed in foil pouches to extend shelf life. And now, let's head to the mango juice factory, the part we've all been waiting for. Here, workers place mangoes into trays and use hand pressure to pre-press them into small cube-like chunks about 20 millimeters in size, helping to release some of the juice and prepare them for the final pressing process. Next, the mango chunks are fed into a grinding machine. This equipment crushes the small pieces into a fine pulp. The resulting pulp is then transferred to a fruit press where mechanical pressure is applied to squeeze out the juice. To obtain a clear juice, the mixture must go through an additional filtration process to remove any remaining solids. The filtered mango juice is then filled into large industrial plastic drums, lined with specialized plastic bags to prevent contamination and ensure food safety. These drums typically hold between 200 to 250 liters of juice and are kept refrigerated or deep frozen while awaiting transport to bottling facilities. Finally, the mango juice is automatically filled into thoroughly sterilized PET bottles, then sealed tightly using heat sealing technology to prevent air or bacteria from entering. This fully enclosed, highly automated process not only ensures food safety but also extends shelf life, so every drop of juice reaches consumers rich in sweetness, smooth in texture, and full of nutrients. From there, it finds its way everywhere. On the shelves of major supermarkets, in family refrigerators, next to a glass of ice on a summer table, or as part of a refreshing, energizing breakfast.